Okay, we're going to go ahead and kick things off. So, good morning. Second day of LambdaConf. Glad you could all make it. Full house. This is okay. So I'm hoping that we spend most of this workshop. I know it's 2 hours. I don't think we're going to use all of it, but if we do, that's okay too. I want to spend most of it hands on keyboard. People exploring Shapeless. How many of you have worked with Shapeless? A few. Okay. Scala. Okay, good. So you don't need to know any Shapeless, but you will need to know some Scala. If you don't know Scala, and especially not some of the more functional concepts, especially type classes, you might want to go find someone to sit next to who does. Maybe you can pair on it together. If you aren't familiar with those concepts, you might find things a little difficult. But if you want to tough it out too, that's cool. When we've got hands on keyboards, I've got about 20 minutes of content, and then we're going to get to it. Feel free to call me over, and I'll see what I can do to help you. So we're going to kick things off. So I'm Ryan Tanner. I am a software engineer at Twitter Boulder. Yes, Twitter has an office here. I work I work in what we call data products, so enterprise paid access to Twitter data. And I do this occasionally by night, I suppose. So you can find me. I'm on Twitter at YouFoundRyan. I don't know if anyone can even read that on the board. You're also welcome to email me if you have any questions, ryan.tanner@gmail.com. Feel free, anything you want to ask. And of course, feel free to come up to me anytime during the conference. So, what are we going to do today? So, quick agenda. Why would we want to encode anything in the type level? Bit of a gimme question, given that we're at LambdaConf. What is poker? I'm not assuming anyone here knows poker. I know we have a bit of an international audience. Not everyone has watched World Series of Poker. So I'm not assuming any level of poker knowledge or strategy. I'm gonna do a very quick intro to that. We're gonna talk a little bit about mathematical induction, because what I wanna start with is kind of how I think in terms of Shapeless. And then I do wanna learn how other people who've used it think in terms of Shapeless. And that's really what the workshop is about. Thinking in these terms and how we model data, model programs with this library. Algebra and the compiler, and then we're going to go into modeling. So the first code we're going to write is just modeling a deck of cards. Modeling a deck of cards in the type level. So some of you are immediately going to start thinking about dependent types and singleton types, and that's definitely the direction to go. And if now would be a good time to Google those terms, if you have not heard of them before. Quick intro to poker strategy. You are not walking out of here with a bot that can sit down in the World Series of Poker and win. That is not the goal. But what we are going to model is classifying starting hands, and I'll go into what that means when we get to it. And the very first stage of poker strategy, which is, do I bet or not, given the cards I was dealt in a game of Texas Hold'em. And it's going to be pretty stripped down strategy. I'm going to ignore a lot. Those of you who know poker well will want to throw something at me, and that's fine. And then how we encode that in Shapeless, or one way of encoding it. There are many, and what I really want to do once we get hands on keyboards is I want everyone to explore, go down dead ends, bang your head into the wall, and with different ways of potentially modeling both a deck of cards and what we're going to do with the deck of cards. There are a number of ways to do it. If someone wants to explore doing it in ways without Shapeless, there's no shortage of libraries doing this. Hey, if someone wants to try it with Liquid Haskell, knock yourselves out. And when we get to the end of the workshop, I'm hoping we can review some of the ways people have come up with in the workshop. We'll throw them up on the screen and see what people have come up with. I'll show you the way I've done it, and I want to see what everyone else gets to. So the caveat, one, I am definitely not a Shapeless expert, despite the fact that I'm hosting this workshop. So I'm not Travis Brown or Miles Sabin. I am not a Shapeless wizard. I've never put this in production, probably never will. And the other caveat is what I said before, we're not actually building a poker bot. We're just going to talk about how to model it. So poker in 60 seconds. Who here has never played poker? Okay. So we're talking about Texas Hold'em, which is the variety you see on TV. And bizarrely ESPN. So betting, 4 things you can do when it's your turn to bet. Fold, check, call, raise. Fold is I'm out. Check is I don't have to do anything right now. I'm going to wait and see what happens. Call is I'm going to put in the minimum. Raise is I'm going to force everyone to put more money into the pot to stay in the hand. So starting things off, 2 players at the table put in blinds. One is equal to a full minimum bet, one is generally half, depends. Once again, I'm glossing over a lot of details. First round, you receive 2 cards. The most important round for this workshop, because it's the only round we're going to get to with actual code, unless someone here is just really ambitious. Every player receives 2 cards face down. You've seen World Series of Poker. They got little hole cam. Those are hole cards. First round of betting. So fold, check, call, raise. What are you going to do? Then the flop, 3 community cards. So you can use any of these 3 community cards plus 2 more coming in subsequent rounds, plus the 2 hole cards to come up with your best 5 to try and win the hand or bluff. Bluffing is also something we're not going to model. Second round of betting, same 4 options. The turn, another community card, third round of betting, the river, 5th community card, final round of betting, and the showdown where everyone who is still in flips their cards over and we see who wins the hand. So that is an extremely simplified overview of poker. Once again, the only one we really care about for this workshop is that first round where you receive your 2 hole cards. Because most of what we're going to get into is using Shapeless to classify hole cards. And I'll show you what the categories that we're going to talk about in a moment. That's the next slide. Classifying those in a very type-safe way. We're going to teach the compiler how to classify hole cards. All of my poker content is lovingly stolen from Lee Jones' wonderful book, Winning Low Limit Hold'em, which is a great introduction to Hold'em strategy, if you are so inclined. So, starting hands. There are a number of ways in poker strategy to talk about starting hands, which are just the 2 cards that are uniquely yours in the game. So we've got pocket pairs, which are pretty self-explanatory, 2 cards of the same rank. We've got big cards, so a suited ace or a suited king, or an offsuit ace or an offsuit king, which would be, for instance, ace, queen, spade, or ace, spade, queen of hearts would be offsuit. Connectors, so that's a 2-gap connector. 10 of hearts, 9 of hearts, and this is a notation you'll commonly see in poker, where it's rank and then a symbol for the suit. And then suited ace king, so big cards would be suited ace and say another face card. Suited ace king would be ace and something way down there. So that's pretty basic. The other variable of strategy, and this is the challenge to you because I haven't figured out a good way to encode this in Shapeless yet, is what we call position. So we're going to talk about a nine-handed game so those are the blinds in the top right that I spoke about earlier. And we're going to say that, play is going to progress clockwise. So we're going to say that the 3 players to the left of the big blind, the first player to the left is the first one, he's under the gun. He's the first one who has to decide what to do in the first round of betting. And we progress around, so we'll say the first 3 are early, second 2 are middle, and the last 2 are late. Why is position important? The later you are in position, the more things you've seen other people do, the better idea you have of what you're up against. So for instance, if you're holding a pair of 5s, and you're in early position, and you go in with it, you're just playing gambling. You're just hoping you're going for pure luck. But if you're in late position, and everyone has just called, then you know you're probably not up against anything all that great, so maybe you'll get lucky, you'll catch a 5, and it turns into trips. But that's about as deep as we're really going to get into poker strategy. I don't want to scare people off with that. So, enough about poker. Let's talk about mathematical induction. I wish I had a whiteboard I could use. So thinking back to, if you have a CS degree, you probably took some kind of discrete logic or discrete structures class. So mathematical induction. So we have something we're trying to prove, and there are, of course, a number of ways to prove something in math, but we're going to talk about our induction proofs. And I don't have a math degree, and I only took like 3 math classes in college, so if I get this wrong, speak up. Let's say we want to prove, can anyone read at all what I wrote on the whiteboard, or is that just a non-starter for this?
Yeah.
You can read it? Okay. Back row, maybe not?
I can see it.
You can see it? Okay. So, you know what, actually, we'll just do it this way. So, an example. So let's prove that 0 plus 1 plus 2 plus n equals n times n plus 1 divided by 2. And this is where I got lazy with PowerPoint. So what we're saying is So how can we prove that? Of course, if you've read the rest of the slide, you already know. So we have a base case. We'll start with n equals 0. So we'll say that 0 equals 0 times 1, 0 plus 1 divided by 2. Which of course is 0 equals 0. So we've proven our base case. And then we can have an inductive step where we progressively increment in and show that given that the base case holds and the inductive step holds, therefore we have proven that this series of 0 dot 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 n equals n times n plus 1 divided by 2. So what does this have to do with Shapeless? This inductive reasoning is very common in Shapeless. So you can think, if you're familiar with H-lists, which are a pretty common construct in Shapeless. In fact, I mean, they're arguably the motivating example for the whole library. You start with your base case, which is nil, or H-nil, which is just an empty heterogeneously typed list. And then you inductively add on to it all of your heterogeneous types. So you have a string and an int and an option of foo, on and on it goes. So the way we're interested in it is in how Shapeless models natural numbers. And this is where we get into singleton types and dependent types. Shapeless provides a type-level representation of the natural numbers being the set of positive integers. So how does it actually model them? That's the end of the presentation, and now we're going to jump into code. For sure. Is that readable? Cool. So this is not the actual Shapeless code. This is just a quick example. So how does Shapeless model it? So we'll start with a trait to represent our natural numbers. We'll call it nat. And it has a type member, which is itself a subtype of nat, an abstract type member. So Shapeless actually only explicitly defines the first natural number of 0. And that is actually the entire definition in the library. Exactly how that works gets into some macro magic, and that's where things go over my head. So we're not going to go too deep into it. The important part for us is that all subsequent natural numbers, 1 and on, are encoded using this successor function. They're not explicitly, well, they are explicitly provided. I'm kind of waving my hands here. But if you poke around this link, which is where the natural number type is actually defined in Shapeless, you'll see exactly what I just showed you. So we've got our successor type, and we have 0. And elsewhere in the library, there's some macro magic going on. But that's so inductive reasoning. Same way that we proved that this series equals this expression, we've encoded the natural numbers using a base case and an inductive step, or a successor function. And then that allows us to provide, that's the wrong library, where to go? Right, so we can reference 0, the rest can't be referenced. We get into the macros. It only provides, I don't remember what the current limit is, it was 22, I think they've bumped it up, because there's some code generation magic underneath the hood. But, so then what can we actually do with that? So let's go into how those are used. So we can compare natural numbers. So we can essentially ask the compiler, prove to me that 0 is less than or equal to 1. And then Shapeless provides this lovely little ill-typed helper, which lets us ask the compiler to disprove an assertion. So prove to me, I'm asking for proof that the minimum of 0 and 1 equals 1. Obviously that's not true. So this will not compile, but we can actually, using this little ill-typed helper, Shapeless lets us put that in the code so that our code will only compile if we have code that can't compile. So that's fun. We can operate on them. We can ask for the sum of 2 and 3. For more basic operations, again, prove to me the sum of 3 and 4 is 10. Can't compile. And then we can mess with them here. Take a sum. 10 minus 10. Well, on and on. So.
I'm sorry, I think I missed one thing. There was only 0 defined, right? Are you using your 1 and 2? Is it like macro or something? Or?
There are macros involved. So that's in, I don't remember exactly where it is in the Shapeless code base.
There's some magic happening.
There's a lot of magic happening. So here's essentially the macro magic. I'll confess, I'm not that familiar with Scala macros. I used them once, and that was kind of enough. So I vaguely know what's going on in here. Yeah, I'm not quite the expert you might have thought I was. But it defines these symbols for us, these underscore in symbols. And then, so you can see here, it's got this loop to recursively define them until it gets down to 0. In fact, this is...
It's reusing the 0 plus successor.
Pretty much. So you can see that this is exactly where it happens, where when we hit 0, we're done. Otherwise, we got to keep, we'll loop until, well, I minus 1, loop decrementing I until we hit 0 in order to define our type level natural number. This is part of why not this specifically, but the hoop jumping is why I don't really use Shapeless in production code. That and it's banned at Twitter. But it's hard to explain to someone. It's difficult enough onboarding someone to a 7 million plus line code base to then also have to teach them Shapeless would be a pretty big detriment to our recruiting effort. So we don't really use this in production. Has anyone ever used it in production? Curious. What do you use it for? For what? Okay. Anyone else?
Implicit lenses for generics.
And what's the use case behind the generics for your code?
We have a lot of similarly shaped structures, and
okay.
Implicit lenses help us reduce boilerplate.
Makes sense. What about?
Return-based classes and HTML forms.
Okay. Cool. Okay, so you're probably using a lot of the type class derivation facilities?
Well, not too much, just like the methods on products.
Okay, cool. All right, so that is a fairly botched introduction to Shapeless.
Yeah.
So let's talk about poker. How do I get my damn... So we're going to talk about one way, if I can, there we go. We're going to talk about one way to model cards. If you have another idea, please feel free. Go ahead and mess with that. And if you have, so at any point, if you come up with something, an alternate way to do it, you want to share it with the rest of the group, you want to explore it, or you want some feedback, or you're stuck on your own, raise your hand. We'll throw it up on the projector and see where we get with this. So let's talk about how I've modeled cards. So we'll start with suits and ranks. We've got 4 suits. I'm modeling them as sealed traits. This is not a purely type level representation, which is why I'm curious if someone else comes up with one. I kind of bridge back and forth between the more standard Scala ADT style and the type level where I am using the natural numbers to represent ranks. So that's why I'm curious if someone has a more pure implementation. I've taken a couple of cracks at it, and they are in here. I can show you them, but I have not gotten one to work just yet. So this is what I've got as our starting point for the day. And then rank, just like the way natural numbers were encoded. I've encoded ranks in a similar way, except without a successor function. You could do it that way. I just didn't see the value in that over just simply copying the line 13 times. So I've given ranks an abstract type of a natural number. The interesting thing about a successor function is you could enforce the monotonically increasing number representing the rank. The question is how much value that really gets you. So I'm going to represent a card as a class with 2 parameterized types, rank and a suit. And so you can see here the big downside from a type level perspective is we have no guarantee as to the uniqueness of our cards. I could define dupes and it would happily compile. Nor do we have any actual guarantee that the cards I define match an actual deck of cards. So if anyone else comes with a better one, raise your hand. So the ranks I've just defined as traits. Each one has its natural number, and the natural number type value is really what's going to let us define the constraints on this. So in a moment, what I'm going to show you is adding constraints on cards. Like this will only compile if you try to instantiate it with a card of rank Jack or higher. And we can do that really easily with Shapeless's facilities for defining assertions on its natural number types. So this is the boilerplate, the deck of cards. So then let's go into a little bit of how I've modeled whole cards, which whole cards are the 2 cards you receive that are uniquely yours. So these are just 2 cards. So let's talk about some of those classifications I showed you a few slides ago. We'll start with big pair. So a big pair, as defined in the poker book I'm ripping this off from, is simply a pair of cards of obviously different suits where the rank is big. So how do we define big rank? And you'll see here I'm going to model it with type classes. So my big pair of whole cards takes 2 cards. They're going to have different suits. I can assert that those suits must be different. So this bit of syntax just is asking the compiler prove to me that the type of S1 and the type of S2 are not equal, because I cannot have whole cards of 9 of spades and 9 of spades. That's not possible. So it's a roundabout way of kind of enforcing the restrictions of the game. And then the other one is in the big type class. So I'm saying that they're going to share a rank, and for that rank there must be one of these available. So how do I define big? So this is where we get back into the natural number type. So I'm going to say you can create one of these implicits if and only if the rank is greater than or equal to Jack. All right, well, where did this come from? So this is we go down the rabbit hole of these constraints until we get one that finally operates on a shapeless natural number. So type of greater than or equal. The extra equals is just to avoid overriding built-ins because that would get nasty. So we've got our rank greater than equal trait. Obvious downside here is that it requires that the larger rank, ignore what I just said. I'm thinking about the wrong one. So where was I? Right, so implicit def, don't need that. Greater than or equal says that you can create an instance of rank greater than or equal if the underlying natural number type is greater than or equal of A to B. And so here we're using a path-dependent type to basically get into these type parameters and mess around with the abstract type within them. So where is this defined as we continue down our rabbit hole? Greater than or equal. I think the newer versions of Shapeless actually provide this as a built-in. When I started this little project, it did not. So this is you no longer would need to write this out yourself. If you are using a more recent version, then you may find that this causes conflicts. You might want to delete that if you had cloned my repository. Right, so here's where we're finally able to say that 0 greater than or equal to 0. So we're back into our inductive reasoning at this point. 0 greater than or equal to 0, that's true. So that's our base case. We also know that any successor function is greater than or equal to 0 by definition. And then we can, this allows us to reason on any 2 non-zero natural numbers. So now we can, by saying, we've given ourselves the facility to say that this natural number is greater than or equal to that natural number through this facility, and then through the rank greater than or equal constraint, we allow ourselves to say that this rank is higher than this rank. And then we can finally turn those into more readable constraints, what you might consider business logic, in the form of big. So rather than just, I could encode this as simply saying, as another implicit parameter here, I could just do another one of these and say that R greater than or equal to Jack. So I could just put that right here. I don't have to use the big type class. It just lets us wrap things up so they're a little more tidy. So if you have not cloned my repository, let me throw that URL back up. You also don't need to clone it. You could just poke around. This is in the misleadingly named alternate cards file in the source folder. So that's where these are coming from. I have a lot of failed attempts. They're all in this repo. I've not labeled any of them, so you can poke around. But that's where these are coming from. If you want to use this as your starting point, if you want to take a look at my failed attempts, feel free to use those as your starting point, because I'm sure there are people in the room smarter than me who maybe can get those down the finish line. And now this is the part where I want you guys to actually start messing around. So I've shown you a basic constraint. I'm not going to go through every single one, because you will fall asleep. So I've shown you some of the basic constraints. The rest are in the repository. This is where I want people to start messing around and defining this. And if you dig through this file, you'll see all the ranks, all the ones I've defined, and there are examples of usage. There will be examples of usage in a moment when I push the repository. Shouldn't have done that during the presentation. So now that that's up there, there are examples of usage at the bottom of the file. One example of usage at the bottom of the file. So you can download that, mess around with it for a few moments, and then I want to see where you guys get, and then I'll show you some of the other stuff I've written, the rest of which is not pushed. So, yeah. Take a whack at that, mess around with it. You know, you can try and create a two-gap hand and see if it compiles or not. Mess around with the other types of whole card constraints that are in there. And then we're going to have a discussion about how we might progress in modeling strategy. I want to get some ideas thrown around and see where we go. And if I've turned you off and you just want to surf Hacker News, that's okay too. I want you to specification about the ill-typed helper that expects a string. It has to be valid Scala syntax, but it should not be validly typed code. If there's any confusion about what ill-typed does, right there.
Would it be possible to create a empty typing Scala?
So there's a bottom type.
Yeah, nothing is.
Nothing.
All right, okay, lots of remembrance.
Similar to C, that's C sharp, and someone probably wondering whether it's doing poker as fine throw. So, I know, so. Oh, so it's just a way of. Quick note on that implicit not found annotation. If you haven't used type classes before, you may not have seen that. It's totally optional. You don't need it. All it does is if you're writing a library that provides type classes, you can use implicit not found to just provide a more readable error message than the one the compiler generates. It's completely optional for this use. It won't impact anything at all if you ignore those. What's up? Good question. So I probably didn't explain quite enough of what some of these classifications are. I've gotten a few questions about that now. So big, medium, small, let's just go over some of the basic classifications in here. Those are basically just putting constraints on the ranks. So low here is defined as anything lower than 9. Big is defined as anything greater than or equal to jack. Medium is 7 to 10, and small is 6 and below. And then so the easiest example is face, because that's a pretty self-explanatory one. It's only the face cards. So if that's how many of you are a little bit confused by that and would like some more detail? There's no pressure. Feel free.
I have a question.
Sure thing.
Why do all the constraints be like big or either high or big, but it doesn't go to base if it's like less than or just I mean, I guess it's just a poker.
Yeah, so that's in the classifications. I can actually show you in the book.
Why would you want a non-base?
That's just the definition. Actually, you may have simply found an error in my... Sorry, which one were you referring to?
I will find it.
Can you remind us the method that will not compile the building type?
So yeah, so that's ill-typed.
Build.
High. The high.
High cards.
Right there.
That is... It's entirely possible that I have a mistake in there. I can't find the definition right now. High card is not. It's an overload term. So I really honestly shouldn't do.
I can't get your most recent file.
Okay.
Yeah. Probably.
I broke the bill. Okay. Yeah, it sounds like I broke. Okay, whatever I pushed to master is broken. You might want to just back up one commit while I take a look at what I did wrong.
So, in terms of the kind of resolution, I was going back and forth, I didn't catch where you thought the super extension was, or what strategy we should be aiming to implement. Like, what needs to be implemented?
So I'm leaving it open-ended on purpose. It's
That's not very helpful.
okay.
So you know, maybe suggest something that we should attempt. Because
Okay. Oh, you know.
okay,
So since you're more familiar, what I might encourage you to do, and I think a couple of the people on the other side who are more familiar with is modeling position.
okay. So, okay. So you just want to model position. So,
Well, modeling to lead into. So let's say this. Aiming for a function, calling that function will compile the position you in the or something that you just and you can I mean I'm not going to so you can define
I might skip the position piece and just look to the function compile if the cards are those that should be.
yeah, so you can say, let's say your security strategy is certainly with so you can write a function that only compiles if you read that, and then you can so this is where we encourage you, so I would is in your commercial numbers, define the, so there are two ways to do it. One is encoding essentially the logic using the constraints provided just to see so there are two ways. One is
Potentially create total order as well.
exactly. And now that's going to be a little tough because it explodes you on the range. But that is a right to do it, especially if you want to start messing with H-lists. And the order you
One could still achieve it by sort of doing a second like a tree of searches where you say, okay, I'm gonna say that this category has this category.
That's a really different part. Yeah. If you want to go down that route, sure. Maybe,
I'll see if I can get somewhere with that.
yeah. So if you're looking for a little more structure than what I've provided, and I'm going to fix the build error in a moment. If you're looking for a little more structure than kind of the instructions I've provided, consider figuring out how to order pans in Shapeless. So for instance, saying that a pair of aces is better than a pair of kings. And your ordering doesn't need to be officially poker. You can kind of make up whatever you want. If you want to do that, I am going to put Mr. NuttyCom on the spot right here. And consider moving over to this part of the room if you guys want to get in a group doing that. He's laughing because I didn't tell him I was going to do that. So if you want to pool your efforts, consider coming over here, especially if you are a little more familiar with Shapeless. You were up next. Okay, the repository is fixed now. I added a file that I didn't mean to add, which is why you shouldn't commit during the presentation. But if you pull master, the repository compiles now.
Thank you.
Sorry about that. Who's hopelessly confused?
I'll ask you one other change
Yeah.
to the Git.
All right, we'll do this first.
Get rid of the build artifacts.
Yeah, get ignored.
Oh, those aren't in the Git ignore.
There are some things in Target that are Git ignored, but there are some things that
They're
are
in
not.
the Git ignore you, but you've already committed them.
Yeah, the same thing's true of project, Target.
We would fix the build there.
And project.
Yeah.
You also have your idea in there as well, I don't know if that's on purpose.
Commit all the things.
You also in there put the project and project and project target in the Git ignore.
If you just put project slash, it ignores both.
Oh, yeah. Well, he doesn't want it. Yes.
You name any, if you do it. Yeah, there's build properties in your
See, you guys are teaching me stuff in the workshop too.
All the best workshops are done.
Maybe some idea in there. We forgot to recurse idea.
We played some this week, so that's just that's disgusting.
See, the real goal of this workshop was to get you guys to teach me how to use Git.
I'd also like to point out something.
Totally.
By deleting that idea folder, I think you wrote idea. So you might want to check out the idea directory from the previous one.
I get RN. I didn't
But that actually, you didn't get RM dash cache, so it actually did delete some.
You're right.
So, if you,
I have an easier solution to that, which is to switch to Vim. And I helpfully named the file I was showing all of you alternate cards, just to confuse you further. It's like a treasure hunt in a programming workshop. You can think of that Git repo more as a brain dump than something I actually should have ever shown to the world. Cool. So, who's kind of lost and not really comfortable? Okay. So,
what's the original task? The build error got distracted.
the build area got distracted. Okay. So, given this kind of set of constraints I've provided here, a basic way of classifying cards and pairs of cards, or whole cards, two cards. Given those building blocks, so I was trying to leave it open-ended, but it seems like maybe that strategy is just leaving people kind of floundering. Maybe that's not been so well received, so I'm going to try and change tack a bit. If you were enjoying that, and you've gone off in a direction you're having fun with, which may be a minority, please feel free to continue. Go down that path. If not, let's talk a little bit about how we might talk about modeling a very basic strategy. So we can classify cards. What do we do with those classifications? And so let's take a whack at that. So let's say that our strategy is we're only going to play cards. We're only going to play hands that are para-jack or better, and that's an arbitrary cutoff. Yes.
You increase the
Font size, sure thing. Cool. So again, if you're going down a path, you're having fun exploring, keep going. And I'm hoping to save a few minutes at the end for those of you who did, so that we can maybe talk about that together. The rest of you, let's go down this other path. We're going to talk about how we, using Shapeless, would use some of these constraints. So our goal now is going to be to write a function. Calling that function will only compile if you hand it two cards that satisfy whatever your personal poker strategy is. And for our purposes, if you have one of your own, go ahead. If not, we're just going to say para-jacks or better. So let's talk about what that might mean in terms of these constraints to say parajack or better. So first let's just sketch out the function. And it's not even going to compile right now. So let's just say it's def accept hand of our first card and our second card. And it actually doesn't even matter what that returns because we're not interested in the return value. So we're just going to say it returns 1. What's up?
Why are you modeling that as a function instead of a case class like you do with two guys?
You can do it either way.
Okay.
In the end, it doesn't make a huge difference. If you want to do it as a case class, that's fine too. The only thing you really can't do it as is a trait, because traits can't take trait. You can't really define a type class constraint on a trait in a way that looks good. Case class or function, totally up to you. I'm going to keep going with the function. Take your pick. So we want to say, let's just start by hand. We're just going to sketch out the hands that we'll accept. So we're saying jack, jack, where suits are a little bit irrelevant.
Should rather than taking cards directly, since we have this set of types that we send whole cards, should we actually be using whole cards instead?
We can do that too. If you want to go a different direction, again, feel free. And also, feel free to criticize my direction. I'm not asking you to keep those comments to yourself. I'm glad when people speak up like that. But that's a good point. So let's try it with whole cards. So quick refresher. I've defined whole cards as this. My definition currently is kind of useless. I saw other people as I was walking around expanding on that, which I really like. But that's essentially why I'm using a function right now, because my whole card definition is pretty empty. We could totally define whole card as something like this, and then it might be a little bit more useful because I could actually take whole cards. But doing it this way, I could also do something like this. Where now I can only compile if I am able to classify those cards. But this still doesn't get us to the strategy we want. We would need, in order for this to work, we would need to be able to order all of those classifications. And I know this is what, I'm sorry, I only know you by your Twitter handle. What's your actual name?
Chris.
Chris. This is what Chris was working on, and he had a great idea about how to model these, which I'm not going to try and pull a route out of my hat and type it out, because that would take me too long to try and figure out all the implications. He had a cool idea, which was think of all of these categories as fitting into a tree, an ordered tree, wherein we can define how these categories relate to each other in terms of, we'll just call it desirability. So that's a really cool idea. I would love to explore that further, but we don't really have enough time, which is too bad. So let's talk about who has an idea of how we might flush out this function. And that implicit parameter is not necessarily the way we're going to go. Any thoughts? Okay, no thoughts.